All right, so a popular topic is Internet of Things, but I want to generalize it to network of things because most of the time you don't need to be connected to the internet. But anyway, just let's see how the technological advancements led us to this concept. So evolutionary change in computing and information technologies happened as follows. Initially, there were only one computer and many users. So people had, for instance, a huge computer inside the building, and people had terminals where they have a keyboard and a monitor, which all of them were using the same computer. But thanks to PCs, personal computers, we reached an age where one user had one computer. So everybody had a desktop computer at their home at some point. But again, technology allowed us to have many computers, but a single user. So as a single user, maybe you have a laptop, a desktop, another desktop at your office, or another laptop given by your company. But also we have mobile phones or a lot of other devices that have Wi-Fi capability or other computational power. Like, you have maybe wireless cameras at your home, maybe even your fridge can connect to internet, and you have smart watches and so on and so forth. So we have one user and many computers. So broadly we can say this is Internet of Things, but main idea here is that there are many devices that have computational capability. So many IoT systems run on resource constrained platforms like mobile tokens without battery, RFIDs, medical implants that do not allow change of batteries, because if you want to change the battery, you have to do the surgery again. So many IoT devices are extremely cost sensitive because they are deployed in extremely high volumes. Industry needed for this reason a lightweight cryptography, because these are small devices, and in order to have confidentiality, your modern algorithms might not fit there. So you have something light. So this is why we needed lightweight cryptography for maybe more than 20 years, but it became an active research area in academia over the last 10 years. Thus, industry deployed several proprietary self-made algorithms, and many disasters happened. For instance, keylog, which is used in cars to, remotely unlock your car, or, garage doors and so on. But it was broken, so you could actually, steal many of the cars. MyFair Classic smart cards are a good example. It is used in many places, like in Oyster cards in London metros and so on. But we can easily clone these cards. So a lot of cards are actually cloned in the past. This is because they designed these algorithms without asking cryptographers, and they were broken. But now similar thing is happening, because in IoT it is cost sensitive, as I explained here. So if you want to put more security there, then you have to spend more money in building them. But current standards actually do not force producers to have this kind of confidentiality. So many IoT devices actually are built without security in mind. So many IoT devices can actually be attacked, especially many IoT devices if you're in the same network with the IoT device, that IoT device generally listens to you and assumes that you are authorized to do whatever you want. So what is the difference between Internet of Things and, maybe ad hoc networks or wireless sensor networks? Because people are talking about Internet of Things, but generally we don't have a nice definition. This is why I'm actually focusing on NIST document, because in NIST special publication 800-183, the title is Network of Things, and they try to explain what are the actors in this area, what are the challenges, and so on. So this picture is from that document. As you can see, there are sensors, and they are gathered in clusters. They are communicating with aggregators. Aggregators are referred to as e-utility, And aggregators can actually send data or perform they can send it to, for instance, a laptop, or they can do computation themselves and make a decision. And with respect to this decision, they can, do stuff, change how the sensors work, and so on. So this is actually how the NIST looks at networks of things. Okay. So let's give a introduction. Again, most of the slides from this point on are from this document, NIST special publication network of things, to, have the basic terms and definitions fixed. So from agriculture to manufacturing to smart homes to healthcare and beyond, there is value in having numerous sensor devices connected to larger infrastructures. This technological advance acknowledges the reality that human society is moving towards smart and smarter systems. The rapid advances in computer science, software engineering, systems engineering, networking, sensing, communication, and artificial intelligence are converging. The tethering factor is data. So as you know, data is the new oil. It is really valuable. This is why you have many free services, like all of the social media services you are using, actually free, because your data is very useful for them and they earn money from your data. There is no formal analytic or even descriptive set of the building blocks that govern the operation, trustworthiness, and life cycle of Internet of Things. So this is a huge problem, and we will see many disasters probably in the close future. A composability model and vocabulary that defines principles common to most, if not all, networks of things is needed to address the question, what is the science, if any, underlying Internet of Things? So this is why I'm focusing on this document. So this document offers an underlying and foundational science to IoT based on a belief that IoT involves sensing, computing, communication, and actuation. So some other people might give different definitions, but this is how NIST looks at the situation, and this is how I want to see it. Because no simple, actionable, and universally accepted definition for IoT exists, the model and vocabulary proposed here reveals underlying foundations of the IoT. This is important because if you look academic papers, which includes IoT or Internet of Things in the title, when you start reading in the introduction, they always talk about IoT devices having constraints, which they are saying that IoT devices are constrained, that they have limited memory, limited computational powers. They are so small that they cannot perform many operations and so on. But on the rest of the paper, they perform operations on Raspberry Pi, which is no different than a CPU or a RAM of a laptop, right? So even since there is no universally accepted definition, this is why contradictions occur even in academic papers. So this is why it is good to have these underlying foundations. So in other words, they expose the ingredients that can express how the IoT behaves without defining IoT. This offers insight into issues specific to trust. We consider IoT to be one type of network of things, and the network of things to be one type of a distributed system. So this is how NIST looks at the problem. Instead of, because network of things covers Internet of Things, because in the network of things you don't have to be connected to Internet. So this is, but of course, a distributed system, right? So they divide the primitives as follows. In a network of things, and these things that the primitives are as follows: sensors, aggregators, communication channels, external utility, decision trigger. Rarely there may be some network of things that do not contain all of these. Okay, so this is how the NIST looks at the problem, and we are going to talk about all of these primitives one by one.